Have you ever wondered what keeps your private messages, well, private? Today, we are going to demystify that invisible shield that protects pretty much everything in our digital world, encryption. So, let's dive right in. I mean, think about it. Every single day, you're sending messages, you're saving photos, you're sharing all sorts of personal info online, and you probably just assume it's all secure. But have you ever stopped to ask what's actually standing between your private data and, prying eyes? Okay, so we're talking about a world of open secrets. Because here's the thing, without some kind of protection, all that data, we're talking emails, bank details, your private chats, it's basically an open book. It's just out there, readable by anyone who knows where to look. And that is where our hero comes into the story. And that hero is encryption. At its core, it's a really simple but incredibly powerful idea. You take information that anyone can read and you just scramble it so thoroughly that it becomes complete and utter nonsense to anyone who isn't supposed to see it. It's basically the digital version of a secret code. All right, let's talk about the art of digital secrecy. So, how does this digital magic trick actually work? Well, it's a fascinating process, really. It turns clarity into chaos, and then back again, all with some pretty amazing mathematical precision. Let's break down exactly how it works. So everything kicks off with what we call plain text. This is your data in its original, totally understandable form. It's the email you just wrote, the document you saved. It's just data exactly as you see it. Anyone can read it. And the process itself, it's actually pretty straightforward. First, you start with your plain text, right? Let's use the message hello. Then you add the secret ingredient. This is the encryption key. Think of it like a secret decoder ring. An algorithm then uses that key to totally scramble the message, and what pops out the other side is ciphertext, a jumbled mess that looks something like AWXFS12B#. And this really shows you the transformation perfectly. I mean, look at that. We go from a perfectly readable sentence, hello, this is a secret, to what looks like a cat walked across the keyboard. It is completely unreadable, totally unrecognizable, and most importantly, it's secure. Without the right key, all that information is just digital noise. Okay, so now we know how it works. But encryption isn't just one thing. It's used in different ways depending on what your data is actually doing. So first up, let's talk about securing data at rest. That means protecting your files when they're not moving. So what is data at rest? Well, it's exactly what it sounds like. It's all the information that is stored on a device. Think about all the files on your laptop's hard drive, the photos on your phone, or the documents you've got saved on a USB stick. It's not going anywhere, so we say it's at rest. So, here's a very real-world question for you. What protects a laptop if it's lost or stolen? Imagine that feeling. You leave your work laptop in a taxi. It's gone. What is the one thing standing between a thief and all of your company's sensitive data on that machine? The answer is full disk encryption, or FDE. And this thing is an absolute powerhouse. It doesn't just encrypt one file at a time, no, it encrypts the entire hard drive. So even if someone yanks the drive out of your stolen laptop, the data is just a scrambled, useless brick without your password, which of course is the key. Okay, so protecting data that's just sitting still is one thing. But what about when it's on the move? That brings us to our next big topic, securing data in transit, which is all about protecting your data on its journey across the internet. And data in transit is data on the move. I mean, every time you browse a website, send an email, or even stream a video, your data is traveling across all these networks. It's going from your device through who knows how many routers and servers, all the way to its destination. And let me tell you, it is incredibly vulnerable during that journey. Luckily, we have some guardians for our data when it's in transit. The best way to think about it is that encryption creates a kind of secure private tunnel for your data to travel through, protecting it from anyone trying to listen in. And we use different kinds of these tunnels for different jobs. So, let's make this real again. Which protocol is protecting your information when you're shopping or banking online? Picture this. You're on a shopping site, you've just typed in your credit card number to buy something. What's the magic working behind the scenes to make sure a hacker can't just snatch that number out of the air? That would be HTTPS. What it does is create a secure, encrypted link between your web browser and the website server. And the most important thing for you to know is that this is what that little padlock you see in your address bar means. If you see that padlock, you're good. Your connection is encrypted. If you don't see it, well, it's not. Okay, one last scenario. How can a remote worker secure all of their internet traffic back to the office? Imagine you're working from a coffee shop. You aren't just browsing one website, right? You're using a bunch of different apps, you're accessing company files, sending emails. How in the world do you protect all of that traffic, and not just what's happening in your web browser? The tool for that job is a VPN, or a virtual private network. And VPNs are fantastic because they don't just protect one little application. A VPN creates a secure, encrypted tunnel for everything, and I mean everything, coming and going from your device. All your data travels through this private tunnel, making it completely invisible to anyone on the outside network. All right, so we have covered a lot of ground, from data at rest to data in transit. But all of this amazing technology, all this complex math, it really all boils down to one single, incredibly important rule. And here it is. Without the key, encrypted data can't be decrypted. That's it. That is the whole game right there. You can have the most powerful, most complicated encryption in the entire world, but it is absolutely worthless if you can't protect the key. The key is the one thing that turns that unreadable gibberish back into something you can actually read. If you lose the key, you have lost your data forever. So when you think about it, encryption gives you this incredible, unbreakable lock for your digital life. But that lock is only ever as strong as the key. Which leads us to the single most important question you have to ask yourself. Who is guarding yours?